Assalamualaikum and a very good day to everyone. So my name is Nur Aziemah Binti Razali, and today I will be presenting my final year project titled Public Address and Passenger Information System using Priority-Based Schedule for Railway Solution. This project was completed under the supervision of Sir Muhammad Ridwan bin Muhammad Razali. Let's begin with project background. In modern railway system, passenger information system (PIS) and public address (PAS) are important tools for keeping passengers informed. PIS show real-time updates like train time, delays, and platform changes on display screen, while PAS helps by making audio announcements so everyone, including those who can't read the screen, can get information. So well work, PIS needs to handle a lot of data quickly, especially from sensors along the track. This helps make sure train details are always accurate and up to date. Old PIS systems were analog and hard to manage, but the latest system use IP-based audio over Ethernet, which makes them easier to use and improve sound quality. By combining both systems into one, operators can share information faster and more accurately, creating a better and safer experience for passengers. Next, problem statement. In many railway stations, PIS and PIS are used separately, causing challenges in delivering accurate and consistent information to passengers. So, I have list 4 problem statements. First, PIS and PIS systems are operate separately, causing confusion for passengers. Number 2, information announced is sometimes different from what is shown on display board. Third, operators must manage 2 systems, which increase the chance of mistake. Fourth, no centralized control system, so updates are not synchronized with real time. Next, objective PAPIS. This project aims to create a smart synchronized announcement system by achieving the following goals. First, study scheduling method to study how real-time scheduling algorithm can be implemented to manage and trigger synchronized announcement efficiently. Second, develop integrated system to design and develop system that combine PIS and PAS, enabling simultaneous delivery of visual and audio announcement. Third, validate system performance to test and validate the system as proof of concept, ensuring reliable performance and synchronization between audio, visual announcements. Next, project scope. The scope of the proposed project is limited to 1. The system is designed for use in a railway station setting. Second, focus on developing public address and passenger information system. Third, includes playback of pre-recorded announcement and view of display content. Fourth, covers real-time updates such as train arrival, departure, schedule delay, and emergency alert. Project significance. The integration of public address and passenger information system helps improve the passenger experience by providing clear, real-time updates that reduce confusion and support better decision-making. Automated announcement reduce reliance on manual input. It's minimizing human error, especially during peak hours and emergency. This system not only improve communication and safety for passenger, but also allows operator to manage information more efficiently and focus on critical tasks. This is literature review map. So as you can see, we have 4 big points here. First, introduction to information system in transportation, role of information system in public transport, importance of real-time updates for passenger, public address, and passenger information system in railway. Next, as you can see here, implementation of real-time scheduling in various problems, embedded system and IoT, robotic system, time-sensitive network, and cyber-physical system. Next, for the similar works, we have studied 3 systems. So first, PIS KTMB, PIDS MRT, PIDS KAI. Next, real-time scheduling algorithm. So we have compared 3 type of real-time scheduling algorithm, which is event-driven scheduling, time-driven scheduling, and priority-based scheduling. This is LR table. So I have list like some big point here, and I have listed down the article and also the key summary. So for the topic information system in transportation, the key summary provide real-time updates to improve passenger experience, operational efficiency, and communication in public transport system. For PAPIS in railway, integrates public address and passenger information system to deliver synchronized audio-visual announcement for clear and faster information delivery. Next, real-time scheduling algorithm in PAPIS. We study event-driven, time-driven, and priority-based approach to manage and prioritize announcement, ensuring urgent messages are delivered first. Next, implementation of real-time scheduling algorithm in various problems. Applied in fields like robotic, IoT, and cyber physical system to ensure timely task execution, adapt to dynamic environment, and maintain system reliability. Next, the similar work. So, it's existing railway project such as PIS, KTMB, Gemas JB, PIDS MRT, PIDS KAI, and it shows practical use of integrated PAS and PIS here. System review. This table presents a comparative analysis between the proposed PAPIS and existing railway PIS such as those implemented in KTMB, Gemas JB EDT, PIDS MRT, and PIDS KAI. From the comparison, it is clear that the PAPIS offers a more comprehensive set of features unlike the other system. PAPIS includes first, manual announcement override capability, which is not available in current MRT and KTMB Gemas JB implementation. Emergency announcement broadcasting, which is critical for safety but absent in the compact system. User authentication and authorization ensures secure access for operator. This review highlights that PAPIS not only matches existing system but also improve upon them by addressing key gaps in manual control and emergency handling. Methodology. This project used the waterfall methodology, which follows a step-by-step process to complete the system. The main phase are requirements, design, implementation, testing, deployment, and maintenance. However, for this final year project, only the first 4 phases are included. The 2 last one, deployment and maintenance, are not required. This approach helps ensure each stage is clearly planned and completed before moving to the next stage, making the development process more organized and easier to manage. System architecture. This system defines the integrated hardware, software, and communication structure that enables announcement, scheduling, and information display through network coordination between the control software, PAS, and PIS. So here are the illustration. So as you can see, the simulated PID server is responsible for managing train schedule, real-time update, announcement logic, and host the database. For simulated PA equipment, it handles communication with the public address hardware and broadcast audio. Next, client workstation. So it manages the content displayed on passenger information screen. Next, PIDS UI web application. It provides dashboard interface for operators to manage announcement and monitor system status. Next, MS SQL database. It functions to store static data and logs. System flowchart. So, flowchart diagram will provide visual representation of system workflow and logic. So, the first flowchart, user authentication and dashboard walkthrough process. So, as shown in the illustration, the user authentication and dashboard walkthrough process, it outlines the step from system login, user role validation, and redirection to the appropriate dashboard interface. Okay, next, manually manage schedule and display. So this flowchart illustrates the process of manually managing train schedule and updating the passenger information display. It covers steps such as checking existing schedule, uploading or editing schedule data, and ensuring the updates are reflected on the PIS screen. Okay, next, this flowchart illustrates the automated announcement process from detecting real-time train status flags to triggering the corresponding audio playback. So the flowchart at the right-hand side This flowchart illustrates the announcement of write process, where the operator directly inputs an announcement for immediate broadcast. It covers steps such as selecting announcement type, entering or selecting message, and prioritizing it over any automated announcement currently in queue. The next flowchart represents the PIDS update process from retrieving the latest train data to rendering the updated information on the passenger information display screen. System design mockup. So this is the GUI interface design for PAPIS system. First, dashboard view. So as shown on the mockup at the left hand side, the dashboard provides a real-time overview of current train status, active announcement, and overall system status for quick operator monitoring. Next, at the right hand side, this interface allows operator to schedule, trigger, and operate announcement as needed, including handling emergency or manual broadcasts. This section enables operator to preview and control the content shown on PIDS, including station name, message, and train update. So, the right mockup, it shows the event log track all system activity, including announcement, schedule changes, and user action to support auditing and monitoring. For system testing, I have listed down 3 main test functionality. So the first one, train movement and events logic. So basically, we determine the correct announcement flag and action based on train schedule. So we will test for the scenario such as expected, approaching, arrive, departure, passing, and cancel train. Second, announcement prioritization logic. So we ensure critical announcement of write others. So as you can see on the list, the first emergency announcement of write all, live announcement of writes automated, pre-recorded announcement instruct automated, priority order. Number 3, PAPIS user navigation. So basically, we test our GUI component. For example, we test for login process, dashboard system monitoring, train schedule management, manual announcement broadcasting, and display board content management, and also viewing event logs. Project timeline. The Gantt chart illustrates the schedule for both CSP 600 FYP1 and CSP 650 FYP2. It's spanning 15 weeks with a semester break in between. The project tasks are distributed as follows. The first one is CSP 600 FYP1. First, project planning conducted during week 1 to 4 to outline objective and direction. Literature review completed between weeks 5 to 10 to support background research. Research methodology developed in week 11 to 13 to define the technical approach. So next, proposal presentation delivered after week 14 as the final task of the semester. Next, for the semester break, data collection and design activities were initiated and continued into the next semester. CSP 650 FYP2, we have development phase. It took place from week 2 to week 11, focusing on system implementation. System testing conducted in week 11 to 13 to validate functionality and performance. Next, for the final presentation, it's scheduled in week 14 as the closing milestone. And lastly, for the documentation, so it maintains throughout the project to record progress and finding consistently. For the conclusion, this project proposed the development of an integrated public address and passenger information system using a priority-based scheduling algorithm to improve communication in railway system. So the goal is to synchronize audio and visual announcement, ensure that important messages like emergency alert and operating instruction are prioritized. So the proposed system will be built as a desktop application using TCP/IP communication to manage real-time update. So if successfully implemented, this solution is expected to enhance passenger experience, reduce confusion, and support smoother station operation in a cost-effective and scalable manner. Okay, that's all from me. Thank you.